Bismillahirrahmanirrahim. My name is Muhammad Shoaib. Welcome back. Today in this tutorial video, we will learn how we can develop a customized logic in the PCS7. So here's one of the example. Suppose you have a two pump and one pump you can consider as a duty and other is a standby. If the one pump is continue running and if that pump is tripped, then you want to run automatically the second pump, that standby pump, and similar manner vice versa. So how we can develop this logic in the PCS7? So here, for example, if my water level is going below than the 2 meter, then my pump will start. And if I trip now this pump, my standby pump automatically turn on. So here you can see my pump 1 is tripped now, and now my standby pump is automatically started, and it will continue run according to my level. Suppose level reach at more than 7 meter, the pump will stop, and if my level goes down like 3 meter, it will still stop, and if my level again goes down more than 2 meter, then my pump will again start. So let's see how we can develop such customized logic the PCS7. So we already created this project in our previous tutorial. So we will use the same. So to create a customized logic in the PCS7, we'll go here, blocks, and right click and insert a new project and create a function block. So we'll add or create a new function block in our project to add a customized logic functionality in our project. So I already detailed video what is a function block and how it's work, and with the practical example I already created a video for it. So I will put in the description. You can watch out that video. So click over the insert object and then select the function block. Then we'll put our function block name. Suppose I will put the name auto logic. Okay, and here in this tutorial example we are selecting the ladder language option and then click over OK. Then double click here. So our FB is open now. So first we will configure the input parameters. So I will write first D duty selector, duty selector which one, and then we can switch to press enter. So this is my one selector switch and this is my duty to selector switch. And after that, like in I require it from the field, then pump 0 drift feedback, This is from the field. Here, strip input from field, then level low, level high. Okay, that's it for the input. Now output side, I needed v01 run, is run, then v strip, and okay. And after that, I will create one more variable. If I want to retain my value in every cycle, I want to save some my value, so I will add it here. I already explained the FB. So now I will add like first I will here add a logic, like once the my level is goes down, then it will latch one bit, and once level is come up again, will dash detach the bit, and accordingly my pump will start at stop. So I will now add one normally open contact, and after that come here in the bit logic and select it from here the set, select and drag it. So I will add it here, level low. Once the my level is low, then I want to set the one bit, that is a level status bit. I will right click, insert a network. Now I will add normal contact and while, and here I will add the level. So once level reach at high level, then it will reset it. Just drag and drop it. Now level status, press it. So same bit, once the my level is go at low level, it will set or latch a level status uh, uh, like variable, boolean variable, and once level reach at high level, then it will reset the same bit. So we'll use this bit in our auto logic, because once the bit is true, in that time only the pump should run. Okay, right click, insert a new network. Now we'll add it here, no contact, one more NO contact, then NC contact, then Y. Okay. Okay. So here I will add, once this level status is there, like once the level is low, only in that time this logic should start. And one more interlock is required. The duty selector should also, duty selector switch also should be the duty switch one, like duty one, like first pump we want to run, then we select the duty selector switch from the field, and then we mention pump 01 run. Okay, now if our pump 01 is stripped, in that case we just putting in the interlock, then the run output should not be. So what happened if the level is low and my duty selector switch is selected and this is NC, so my pump will run. So if the pump is stripped from the field, then this will break the logic, then at that time stop. So similar manner, I will insert a new network, and similar manner will create a log for the second pump. So see, and same manner, level status. If the level is low, that time pump should run. Here I will select the duty 2 selector switch, and similar manner you will select the pump trip, pump feedback. Actually it should be the feedback should, and here also pump should, this is from the field signal, and then the run. Okay, perfect. So here also the once level is low, in that time duty 2 is selected and if pump is not tripped, that case our pump will run. Now we want to interlock. If my pump 1 is duty 1 is selected, and in that time if the trip is pump 1 trip is activated, that time this pump will stop. So I want automatically the pump 2 should stop. So what we can do, right, click it here and then click over the open branch and then put one normally open contact, and after that select it from here end and then joint it here the middle, these two contacts. And now here I will like add it. Okay, so UT2 duty switch, yeah, duty switch 1 is selected. Okay, and P01 trip feedback. Okay, so in this case what will happen, so if the my this pump is tripped, in that case so level status we are getting because the level is low. So if the duty 1 switch is active and if the trip from 1 trip feedback also we receive, in that case the it will run automatically the pump. So similar manner will create a logic for the pump 1 also, and here we'll add the switch. Here we'll add trip feedback. Okay, perfect. After that, right click here, insert a new network, uh, insert in last here. Okay, so we'll take NC contact now and then coil. Okay, so here I will add pump 01 trip feedback, and here I will add pump 01 trip. So why I add here NC contact, because I will link this trip output with my motor block. So motor block in the healthy state is required for one condition. That's why I put it here. See, once the trip is active, so if it will become 0, so motor block will detect the okay some trip state. Similar manner for pump 2, I will add it P02 trip back, Okay, so our customized logic is ready now. So I will click it here to save. Click here, yes, and then close it. Okay. Now come here in the mixer and then right click here, open, click the mixer and right click and insert a new CFC chart and put the name of the chart. So the name, you can put any name just for example. Then double click here and open it. So our CFC chart is open now. Now come here in the block and the plant. So here you can see our FB1 auto logic is there. Select it, drag and drop it. Click yes. So this is our auto logic block. So now here you can see we already created our inputs or block inputs like the duty selector switch 1, duty selector switch 2, and after that trip feedback, from 1 trip feedback, then levels, and after that our codes. So take data from the input. We have to configure our input channel driver. So come in the libraries, then APL library, then here channel, and you can select the digital input. Select it, drag and drop it there. Okay, so we need 1, 2, 3, 4. So we'll add 4 digital input channel driver. Add one. Now we have to add our input signals. So ARD added, go in hardware, select it, and digital input to right click, edit symbol. So here you can see I already added for I 1.0 trip and similar manner 1 and 2 for the I 0.0. So close it. So I will right click, select the interconnection to address. So here the first is duty 1. I will select the duty 1. Second is my for the duty 2. And then this one is for my trip signal on one trip, and this right click on trip. Okay. So we successfully configure the input channel drivers. Then we will connect the PV out with our duty 1 selector switch, select PV out pin, and then click over the duty pin, and similar manner for the trip 1, and here for the trip 2 also select the PV out, click it here. Okay, so duty 1, duty 2, and trips will link with our customized block. Now we'll open level transmitter. So here you can see we already have a level transmitter CFC chart. We'll open it. Okay. This in our previous tutorial we already created this level transmitter block. Okay, we just take the here for the analog input channel driver, and after that we will put the scale value, and then we put the level unit, and then we add a one monitoring block from here, monitor, and here this we added, and after that we input the maximum level, scale level, and then we put the unit. Some additional setting I also did. Go in the object property, to go in iOS, and here you can see the maximum limit is default, some other value is there, so I just put it for high limit 9, and high warning 7, uh, low warning, and the low alarm 1. And one few more setting we did it, like from here you can see. So here you can see the TV low alarm, configure it. We click it over the invisible similar manner, low, active, and higher, and higher. So here that's why it's coming here. So we link like the high warning, like select the high warning pin and go in Windows and select the motor logic, and we link with the high. Click it here over the level high pin. Okay. Now we'll go back again the level, and this time we'll select the low warning output pin, then go in Windows, then motor logic, and select here the level. So now we configure the our customized logic block input all parameters. Now we'll go toward the output side. So output side first is the pump 1 run. So we'll come here, pump 1, and open the pump 1 CFC chart. Okay. So here now we'll connect back those and logic. Select the pump 01 run output coming pump 1, and click over the start auto. Okay. Now we'll go, we select now here the stop auto, and then back logic, and we'll select again same. Okay. Now right click over the stop auto and click over the invert, because once the bit is here true, so in time we want to invert the same state. The pump is here true is coming, the pump should start, and then here should get the stop command same time. So similar manner, go for the pump 2 also. Just select the pump, open the CFC chart for pump 2. So we'll select this start auto pin from here in the logic and select this run pump 2. Okay, we'll again select same run and go in the and connect with the stop auto of the motor block. Okay, right click here and invert the stop. Now we'll go back in our logic. So here we want to now connect our the trip output also the motor block. Select it here and go to the pump 1 area and click it here to link that it with the trip motor. And similar manner, select the pump trip and go and connect with that. So now here you can see we already linked the permit block with our motor also, because the motor should not run until the wall is not open. So we already put one more in block. So that's it, our logic side. So we'll close it and now we'll compile our project, and after that we'll download. Okay, so our project compiled successfully, and right click and PLC and click down. Click OK. Yes. Okay. Click yes. Click yes. Right click file. Click next. Again next. Okay. Next. Next. Compile. Click check and here in graphic designer go down on the mixer picture. Here close. So miscellaneous display with this also miscellaneous display is and recheck. But here you can see with the maximum scale 10 100, and after that we link. Here you can see the tag. We just link. You have to right click here, select the tag, and after that right select the tags. After that you have to select the proper tag. Okay, like our case we select the level EV underscore out, that value cancel. You can see this tag we select. The rest all is same. Just click save and just close it. So now click here on the project. So our runtime is over. Click over the mixer. So run the motor. As you can see, the boat motor is right now in the manual mode, and it's interlock, or our wall is closed. As you can see, the permission interlock is active, and if you click over the permission, you can find it here. The wall is closed now. So now we'll open the wall. Okay, then again, okay, and now we'll put both motor in the auto mode. Select, then click second mode also auto mode. Okay, now we'll turn on our duty selector switch. So once I turn on the duty selector switch, in my logic I already configured if the level is low, here you can see level is, and duty selector switch is on. If motor not tripped, then my pump should start. So as you can see now my pump is start. Now it will work according to my level. Suppose level is going, for example, above the set point. So my level is normal, and if my level is go above than high warning set point, that is 7, if level go above then you can see my motor is stopped now, and if now level coming down again, so still my motor is stop, but once level reach below than one, below then my motor will start again. So suppose if right now my motor is running, I already developed a logic. If the motor one is running and if it is a trip, so then the control shift to the second pump, like this motor may working as a duty and the second motor is working as a standby. So if this one is tripped, then the standby motor should start. So we'll simulate it. So here is my the on one trip input. If it is activate from the field, so you can see now the my motor one is stripped now and the motor two is started now. Now motor two, according to level, it will fill the tank. Suppose if I will increase my tank level, suppose 6 still is turning, level go above than 7, so it will become stop. You can see, uh, here you can see if I will put it down again. So still motor is stopped, and we can see also in the CFC chart also select it and watch on. Press the control key, select all of the inputs and also the outputs also. So here you can see right now my pump 2 is stripped and duty 1 is selected and now no level input is coming. So if my level goes down below than, so again my this motor is running, and here in the chart also you can see the same behavior. So level low is coming accordingly the my is running. So suppose now if the some technician went at site, they fix the issue, they reset the trip, and now if I will remove this strip and if I will remove the trip, you can see this motor is stopped now, and now we have to clearly from the motor block, we have to reset it, this trip from the base plate. So here you can see this reset is appear option is appear. If the, for example, I will turn on it again, so you can see the behavior. If it is still stripped from the field, here it will be become disabled. The reset button is disabled. But if the reset feedback is removed from the field and somebody clear the reset, trip reset, so in that case, it will this reset button will appear. So now we'll click over the reset button, reset. Okay. So after reset, now our motor one again will start automatically. And now if I will increase the level, suppose my level is 7.6, now we stop now. So if I will change the duty now from 1 to duty, and now my level goes down again. So then, so now you can see I select the duty 2, like, so now my motor 2 is working as a P and the motor 1 is working as a standby. And also you saw in when we trip the motor, then we require a reset from the air motor faceplate. This reset button is here now. So in our previous tutorial video, we learned some of the interlocks options like permit, interlock, and protect. And now here in this tutorial video, we use the trip option also. So actually, what is the difference between this all? Like the permit, first, the permit we use in this video tutorial for the walls permit, like the prerequisite condition should be true. So in the wall, once the wall was open, so it's showing the some permissions or permit interlock was active. So in this is only required for the initially before start the motor. If the motor is start, then it will not check this permit or permissions interlocks. Then we have interlocks options. Like interlock, once it's activated, the motor will become stop on that time, and once it's normally or healthy, then motor will start again. But the protect case is different. In the protect case, if the protect interlock is activated and once it's become healthy, the motor will not start automatically. We must have to press this reset button in that case. Now the fourth option is a trip. Trip, if the trip is active and from the field, like the as we saw, the pump is stripped from the field. In that case, also we must require a reset button. So almost protect and trip is a similar. But what is the difference? Like the if the protect is activated, here you can see in the faceplate some symbol, or on the motor also you will you can see the some lock symbol. And but if the trip is active from the field, in that case the motor this symbol icon color is changed with the red symbol. So that is just difference between these different types of interlocks. So Alhamdulillah, in this tutorial video we'll learn how we can develop a customized logic in the PCS7. So thanks for watching this video.